Hello everyone, welcome to day 3 of geometry. What we'll be doing today is identifying multi-step rigid transformations on the coordinate plane. Our central questions are the same. How do we apply our social, emotional, and metacognitive skills to geometry? What are real-world applications of congruent figures? Our agenda today is that we will be going over our goal setting, which you should have completed already. We'll be reviewing some key terms and definitions. We will have a mini lesson, and then you will have some activity choices and a graded ORQ and reflection. So, as a review from the previous days, we have two key terms and definitions. The first is our pre-image and our post-image. Your pre-image is the original figure before the transformation. So, for example, A, B, C, D. And I also want to thank you for your feedback about writing in cursive. I apologize. I had written these answer keys before I had that feedback, so I will make sure to write in print moving forward. However, for today, you may have to bear with some cursive. Okay, our post image is our image after the transformation. So for example, A prime, B prime, C prime, D prime. So your primes are your like little apostrophes, and they indicate your post image. And if you have multiple post images, there's a good chance that you're going to have double primes. So like A double prime, B double prime, C double prime, D double prime, or maybe even a triple prime. So A triple prime, B triple prime, C triple prime, D triple prime. Next, you have rigid transformations. As a reminder, rotations or your turns, reflections or your flips, and translations or your slides are rigid transformations, and they preserve angle measures, side lengths, perimeter, and area. So again, rotations, reflections, and translations are rigid transformations, and they preserve angle measures, side lengths, perimeter, and area. Next, we're going to go on to page 2, and we're going to do a quick rigid transformation review. So on the far left-hand side, we have a rotation or a turn. As a reminder, the easiest way, I think at least, to identify your rotation is to draw arrows or draw a line from your vertices to the origin. In this case, you're drawing a line from your A prime to the origin and your A to the origin. And we can see that this is a right angle. And if we're going from our A to our A prime, from our pre-image to our post-image, we're going counterclockwise. And so I drew an arrow to show that this is counterclockwise. So I labeled this as a rotation, which means a turn. And I wrote out the sequence. And as a reminder, you have some criteria for success for your sequence. You have your pre-image, triangle ABC, is rotated, that's your rigid transformation. 90 degrees counterclockwise about the origin. You have your degree measure, you have the direction, and you have the point about which you are performing the transformation. So this is the origin to create triangle A prime, B prime, C prime, and that's your post image. Next, in the middle, we have a reflection, and that's a flip. The way I remember this is reflection has an FL, as does flip. And in this case, we're looking to see what is your line of reflection to create a mirror image. And so if I were to label this D, E, F, and D prime, E prime, F prime, I'm going to look and see what line am I reflecting over to create a mirror image. And in this case, it is x is equal to 1. And I can check this because if I check each point, D to the line x equals 1, there's a distance of 2 units. And if I were to check from the line x equals 1 to D prime, it's also 2 units. So that is my line of reflection, and it is x equals to 1. As a reminder, if you're not sure how to write the equation, so for example, if you don't know if it's positive or if it's horizontal or vertical, or you don't know if it's y equals or x equals, I would actually just put some points on the line. So I'd put 1, 1, 1, 2, and I realize that all of my x's are equal to 1. So my line is x is equal to 1. When I write out my sequence is triangle DEF is reflected over the line x equals 1 to create triangle D prime, E prime, F prime. So in this case, I have my pre-image, triangle DEF. I have my post-image, D prime, E prime, F prime. I have shown my type of rigid transformation, which is a reflection, and I've said the line over which it is being reflected. That is my line of reflection. Next, what I have is a translation. The way that I remember that is translation has an SL, as does slide has an SL. And I think, how am I sliding from my H to my H prime, my pre-image point to my post-image point? And in this case, I'm going to the left by 4 and up by 3. And so I can use this arrow notation or this algebraic notation, quantity, or I should say the coordinate point x comma y is becoming, that's your arrow point, x minus 4 and y plus 3. As a reminder, your x tells you your horizontal shift, left and right. If it is left, it is minus. If it is right, it is plus. And your y shows your vertical shift. So if it's positive, it's going up. If it's negative, it's going down. I'm going to write my sequence. My sequence is quadrilateral EFGH is translated left by 4 units and up by 3 units to create quadrilateral E prime, F prime, G prime, H prime. So my criteria for success is that I have my pre-image EFGH, I have my post-image E prime, F prime, G prime, H prime, and I have my translations for both my vertical and my horizontal shifts. So left by 4 and up by 3. Okay, next we're going to move on to our mini lesson. So one of the things that you'll be working on in your QPA is working with real-world patterns. So what I've done for you today is prepared a few different tessellations or repeated geometric patterns, and we're going to practice mapping one shape to the next. And so we're going to use this following coordinate plane. The first one says, our first point says, use a straight edge to create axes and scale on the coordinate plane below. Include labels for your axes. And so I think whenever I'm drawing an origin, I probably want it to line up with one of my vertices. So in this case, I'm going to label it quadrilateral 1, A, B, C, D, and then I'm going to line up my origin 0, 0 at this point A. And so draw in your x-axis and label it x-axis. Next, draw in your y-axis and label it y-axis. Next, let's go ahead and label quadrilateral 2 EFGH. Now we're going to think about, even before that, I realized I forgot we need to label the scale of our axis. And in this case, it looks already like a coordinate, so I think each box is going to be 1 unit. So 1, 2, 3, 4, 5, 6. To the left by 2, minus 2. Up by 1, 2, 3, plus 3, and 1, 2, 3, 4, 5, minus 5. So at this time, you should have your x-axis and your y-axis labeled. You should also have you should have some of your scale labeled. So I should see a plus 6, a minus 2, a plus 3, and a minus 5 to show our coordinates. We've already, I believe, labeled quadrilateral 2 EFGH. If not, go ahead and label it. And next, we're going to determine a sequence of rigid transformations that will map quadrilateral A, B, C, D to quadrilateral EFGH. And we're going to just justify our answer by plotting the intermediary quadrilateral. And what I mean by intermediary quadrilateral is it's the quadrilateral that's going to be in between A, B, C, D and EFGH. Now I noticed this parallelogram has a point, and I want to see, how do I make this point A match up with point E? And I think one way to do that is to have your point A rotate 90 degrees counterclockwise to create this quadrilateral. So now it's in the same, I guess, almost like a direction as EFGH. So I drew my arrow of rotation, I drew my intermediary quadrilateral, and I'm going to go ahead and label it. So if I rotate this 90 degrees, my A is still in this, if I'm rotating it about the origin, which is point A, if I were to rotate B all the way up here, that would be B prime, C would come up here, and D would be over here. Next, what we're going to do is we're going to translate A prime, B prime, C prime, D prime, right 3 units and up 2 units. And so let's move with C. It goes 1, 2, 3 right, 1, 2 up. And that is our translation. And that's going to create E, F, G, H. And our algebraic notation is x comma y, and x plus 3 and y plus 2. So that means a horizontal shift to the right of plus 3 and a vertical shift of plus 2. Okay. That is your mini lesson for today. Next, you will have guided and independent practice. So you're going to choose an activity that best meets your learning needs. So regardless of which learning activity you choose, everyone's going to be assessed using an ORQ that includes information from these activities. You will also be doing a reflection based on your goal setting. Your ORQ and reflection will both be graded. If you finish your activity, go ahead and try another one. So you might want to look through your 1, 2, 3 feather and maybe even the 5 feather activity and determine which one is going to best support you to get 100% completion and a 4 out of 4 on your ORQ. Good luck, have fun, and I will be talking to you soon. Bye.